Welcome to Mitchell Maths. In this video we're going to be looking at advanced indices. So this is for students who are studying the higher paper, and I'm going to assume that you have some basic knowledge of indices, and if you struggle with some of these questions, maybe check out my earlier video which is for foundation and higher students and just goes through some of the more basic concepts. So for question 1 we need to write the following indices as fractions. And we can see in the first question we've got 7 to the minus 1. And when you've got a minus, you sort of have to write the answer as a reciprocal. So like 1 over, or flip it around if it is a fraction. So we know that 7 to the power of 1 would be 7. But because it's 7 to the power of minus 1, it's going to be 1 over 7. In part B, we've got 4 to the power of minus 2, where we know 4 squared is 16. So 4 to the power of minus 2 would be 1 over 16. Part C, we've got 3 to the minus 3. So that's going to be 3 cubed, which is 3 times 3 times 3, which we know is 27. Therefore, the answer to part C would be 1 over 27. So what you can see is when we have a negative indice, it's going to be 1 over that. Now, let's say if it had been a fraction, your answer, then you just flip over the fraction. So, for example, if your answer had been like, I don't know, say 2/5, you'd switch it over so it was 5 over 2 or something like that. Okay, so that's what I mean when I say flip over. So that's how you do negative indices. Question 2, we're going to find the values of the following. So here we've got indices, but they're fractions. And when you have fractions like a half, a third and a quarter, a half with a 2 on the bottom means you're going to square root. A third means you're going to cube root. And a quarter means you're going to do like the 4 root of that number. So for 25 to the power of a half, as I say, because it's got a 2 on the bottom, we're going to square root it. So that would be, the square root of 25 would be 5. For the next part, it's 27 to the power of a third. And because there's a 3 on the bottom, we're going to cube root it. So it's going, the cube root of 27 is 3, because 3 times 3 times 3 is 27. And for part C, we've got 16 to the power of a quarter. So we're trying to find the number that multiplies together 4 times to get 16. And that's, of course, going to be 2, because we know 3 would be 81, 2 would be 16 when it's multiplied 2 times 2 times 2 times 2. Now in this next one, what we're doing is we're mixing the fractional indices with the negative. So what we need to think about, first of all, is what is 49 to the power of a half? Well, we know to the power of a half is a square root. So 49 to the power of a half would be 7. Because it's negative, it's going to be 1 over 7. We've got 125 to the power of minus a third. So 125 to the power of a third, well, we know a third means you're going to cube root it. So the cube root of 125 is 5, because 5 times 5 times 5 is 125. But because it's negative, the answer is going to be 1 over 5. So you can see what I'm doing is I'm just working out what it would be without the negative, and then I consider that it has a negative indice and just flip it over as 1 over. Question 4. So these again are fractional indices, but now there's a number that's greater than 1 on the top of the indice. So let's have a look at the first one. We've got 8 to the power of 2/3. Now, because it's got a 3 on the bottom of the fraction, you're going to first need to cube root it. And we know that the cube root of 8 would be 2, because 2 multiplied together 3 times gets you 8. So that's going to give us 2 squared. And 2 squared, because a 2 is on the top, and 2 squared is 4. So we're going to do the same for the next one. So you always work out the parts on the bottom first, and then you look at the top. So we've got 81 to the power of 3/4. So first of all, we want to work out what the 4 root of 81, what number multiplies 4 times together to make 81, which is 3. And then we need to cube 3. And that would give us 27. So that's part B. Now for part C, we've got 25 to the power of 3/2. And again, we're going to do the same thing. We've got a 2 on the bottom of the fraction, that's the indice. So that means we're going to have to square root 25. And we know the square root of 25 is 5. And because it's got a 3 on the top, that we're going to need to cube it. So 5 cubed is 125. And you might know that off the top of your head, or you might just have to do 5 times 5 times 5. Either way, you'll end up with that answer. Now question 5, it goes a little bit different. We're working sort of backwards, because now we're looking for something written in the form as 3 to the power of n. And the trick with these types of questions, when you've got 2 numbers, is you have to first get both numbers in this format. So we need to think, can we write 9 as 3 to the power of something? Well, we know that 3 squared is equal to 9, so we're going to write it as 3 squared. And square root of 3. Now, the problem is we don't have an indice value there, but we know that the square root of 3 is the same as saying we've got 3 to the power of a half, so that's how we're going to write it. And now we're multiplying the indices together. And since we're multiplying the indices together, we're going to need to add them. And that would get us 3 and 2.5. And what I'm going to write it as, I'm going to write it as 3 to the power of 5/2, because the fraction 5/2 is the same as 2.5. I've just written it as an improper fraction. If you had 2.5, improper is the same as 5/2. For part B, I've got, again, I'm going to write it as 3 to the power of n. So I've got 1/9. And I need to think, what is 1/9 as 3 to the power of something? Well, I know that 3 squared is 9. So if I've got 1/9, it must be 3 to the power of -2. Because if you remember from the other questions, when we go 1 over, it's a minus indice. And we're going to multiply that by 3 to the power of 5. And when we multiply them together, we add them, but because one of them is negative, it's going to be 5 minus 2. And that's going to get us 3 cubed. And I know we know what 3 cubed is, but we're going to leave it as that, because that's what we've been asked to give our answer as. And question 6, so this is another one like the other one, but with some harder questions. And we need to write in the form as 2 to the power of n. 8 we can write as 2 cubed. And now we've got the square root of 2 cubed. Now, because we've got a square root, that's like an indice of a half. And we've got 2 cubed. It's almost like saying we've got 2 cubed, and then we're going to square root it, and that's like a half. So what you do in this position, where you've got like that type of indice where they're both together, is you multiply the indices together. So it'd be 3 times a half, which would give us 2, and to the power of 3/2. So if I go through that, because it's 2 cubed, and then we're square rooting it, which is to the power of a half, and that's how I've got this here. So the square root of 2 cubed is the same as that. That's just writing in a different form, and that's just so I get the square root as an indice as a half. So I'm going to write this as 2 to the power of 3 over 2. And then when you multiply indices together, you add them together. So 3 plus and 3 over 2 is 1.5. So 3 plus 1.5 is 4.5. So you could write it as 4.5, or you could write it as 9 over 2. Because the question doesn't tell you need to write it as a fraction or a decimal, so either would be fine. 2 to the power of 9 over 2 or 2 to the power of 4.5, either would be acceptable. Now for the next one, we've got, first of all, we've got 4 to the power of 3. Well, we can write the 4 as 2 squared, so really it's 2 squared to the power of 3. So we get this situation again, and here what we're going to do is we're going to multiply the indices to get 2 to the power of 6. So 4 to the power of 3 written as a 2 to the power of something is 2 to the power of 6. And we've also got 8 to the minus 1. Well, 8 to the minus 1 is 1 over 8. And we know that 8 is equal to 2 cubed, because 2 times 2 times 2 is equal to 8. But because it's 1 over that, it's going to be a minus indices. So instead of being 2 cubed, it's going to be 2 to the minus 3. And what we have to see here is it's a division. And when you divide indices, you take them away. So we've got 6 minus 3. And because we've got a double negative, we're actually going to add that 3 because we're taking away a negative number. Therefore, we're going to get 2 to the power of 9. And part C, the final part. So we've got 8 to the power of 2/3. And what I'm going to do here is I'm going to do a similar thing to what I did to the other ones. I'm going to write the 8 as 2 cubed. And then put it in brackets. And I've got 2/3 outside the brackets. So that's 3 times 2/3. Well, 3 times 2 is 6. Which means it's 6 over 3. And 6 over 3 simplifies to 2. So it's like saying 2 squared. So that's going to be my first part. I could have actually, probably the cube root of 8 is 2 and that leaves you with 2 squared. But so you can do it either way. And the next part, I've got 16 and the cube root of 16. Well, 16 is 2 to the power of 4. And then because we're cube rooting it, well, if we remember earlier, cube root was the same as saying to the power of 1/3. So I'll write that there. So we've got 4. And then we need to multiply the indices. So we've got 2 to the power of 4 and we're going to times the 4 by 1/3. Which means we're going to have 2 to the power of 4/3. And then I'm going to add them together. Now, I'm adding 2 to 4 over 3. And what we do is we convert 2 to a fraction over a 3. And as a fraction over 3, it is 6 over 3, because 6 divided by 3 is 2. Plus 4 over 3 equals 10 over 3. And the reason why I'd always keep this as a fraction is because when you divide something by 3, it becomes a decimal. Unless it's an exact number. So we've got 2 to the power of 10 over 3. Right, so thank you for watching. Hope you found that helpful. If you'd like to see more videos for tips on different topics, please hit the subscribe button. And if you'd like to see some practice questions, please visit my website, www.mitchellmathsandscience.com. Thank you.